Good morning. I'm Cody Henriksen, and today we're going to be taking a look at the data definition language, the DDL subset of Squirrel. All right. So we want to take a look at what we're doing with the structure of the database. So when we're talking about DDL or data definition language, we're talking about what we're going to be making or destroying within the actual database management system. These can be structures, individuals, groups, actions, and or tools. And there's a whole bunch of stuff to be looking at. We're going to look at the basic overview of what we can work within that, and we're going to focus on a few of them and go into some examples to see how it works and look at it as an actual database using terminal. Let's go take a look at that. The first one we want to take a look at is the create statement. The create statement is amazingly powerful. As you can see right here, there's a whole bunch of different things we can make. Databases, tables, views, indices, roles, users, functions, procedures, and trigger entities. Yeah, I know, there's a lot. So we have database, table, and view. Those are the structures we actually use on a regular basis inside the database itself. The things when we're talking about the data structures that we're working with, yeah, we'll make those all the time. And index is a tool we can use to increase our retrieval speed, and we'll take a look at that in one of our advanced videos. Roles and users are how we can actually get groups or individuals together with access, and we'll be addressing that as part of our DCL language video that we'll be working with in just a bit. Functions, procedures, and triggers are all different types of events and or methods that work within the database, so we can have specific things happen or call upon as other interact with the actual data itself, and we'll be working with that on another advanced video as well, but we want to make sure we talk about how you can actually create them using the basic syntax of this. So we have our create database syntax right here. As you can see right here, I have a create database alternate universes, followed by our great friend, the semicolon, and then we use the use statement to say, hey, this is the database we're going to be talking to. So the create database syntax is really quite easy, but when we're working with this, after we call the create database syntax, the most important thing we want to make sure we do is we tell the database system, in this case MariaDB, that we're working with, that we're going to be using that database as well. So those two often go directly hand in hand so we can actually work with them, and we'll see that actually as an execution statement when we go through and actually do the example of this after we go through the lecture. So we have the create table syntax. Let's talk about the actual structure of how create table works before we actually run through and give a real world example and go from there. So we have the create keyword, of course, and the table keyword, because those are the two things we have to first talk about. Then we have our table name. And so we have create table name, and then we have parens to identify that we're doing a lumped conjunction of things. There's a whole bunch of code going in there, so it's separated with parens on there. All of our field names get separated one line at a time. And so you have the field name followed by a space followed by the type. Any modifiers that go on that. And because I'm obsessive about this, they're all not null. I'm sorry, but when I define a database, I don't want to risk the chance of giving bad data to start off with. So I explicitly give a not null restriction on all of my data members that belong to a table. Every other field is going to be separated with a new line and commas at the end, as you can see with those examples right there. Now, this is not going to compile, of course, because it's not real. That's, I mean, other field and type are not the things, but, you know, that's the idea. The next thing we have is the engine type. We're going to specify the engine when we create our table. Now, we're always going to use InnoDB. That's the default storage engine inside MariaDB, and it's the one that we'll be working with all the time. But there are actually other options, Black Hole being one, MyISAM another, but InnoDB is the one to go. We're good. The default char set. So the default char set is where we're going to say, hey, what kind of symbols do you want to use? Now, this is, again, when we talk about this, we are going to be working with the expectation that we are not only working with a single type of data set. And so my minimum specifications for my classes is always going to be UTF-16. UTF-32 or 64 are also great as well. But we are dealing with Unicode-based language. We're not going to restrict ourselves to the only ASCII character set. So we want to make sure that all symbols available are possible. So we want to make sure we use a good symbol structure on that for the char set. The second thing we have on there, the third thing that we have on there is the collation type. And this means how we're going to evaluate the actual symbols we're working with. And so in this case, UTF-16 binary, we're going to be making sure that everything gets evaluated on its own. So there is a case difference, then guess what? They're evaluated differently when we actually do comparisons inside there. Because that makes a lot more sense, especially with modern programming style, that uppercase and lowercase, they're actually different things, and we care about that as a programmer, and we want to make sure that our client's data is also maintained with that. Finally, the last statement is comment. I'm very big on the idea that we want to actually explain what's happening inside our data sets and inside our databases. And so I want to make sure that we always give a comment statement to that. Notice I'm using the plain single quotes for separating that information out. And then after we describe what's happening inside there, besides simply the table name and what fields are attached to that, we close with a semicolon saying, hey, we're done with this statement, we're good to go. We also have the view. The view is a new thing beyond simply a table, because oftentimes when we want to give access to different parts of the database, we don't want to give them either direct access to the database, or we want to give them a custom view of that data. And so there's a couple different things we can actually do when we're talking about that view. We can do a simple view, or we can do a much more complex view. With a simple view, all it's really doing is creating a view with a name. So we're naming something. It has to be its own unique name, of course. And then we use a select statement to build that view. In this case, I have create view name as select fields separated by commas from table name. So it's just going to take those 3 fields out of that table, and boom, there's that view. And they can interact with that, do queries and stuff, just using that information right there. We also have the ability to create a much more complex view where we can create, for example, a report or some other information we want to use. And this is a great way when you're exporting your data and putting it out in a way that's going to be used by some other entity. For example, a web server, a program, or something like that. And this is a great way we can actually create more information and share it with that. In this case, we're going to create view name as select table1.field table2.field table n.field from table 1 join table 2 on table1.id equals table 2.id and union that with table n. Of course, assuming that all those are perfectly matched, but hey, that's okay. But we have that information right there, and so that's how we can get a complex view, and it can generate some really great information when you actually use. We'll see more examples of this as we go into the actual view lecture, but for the idea right here, we can see the basic structure of what we have to do with that. The next one we have inside the DDL statements is the alter command. The alter command is how we actually change what's going on inside the database, and it has the ability to do so much to the database. So we really want to make sure we're careful with this. This changes the actual structure of the table, or theoretically the database, but we're not going to ever change the collation of the data set because, well, yeah, that doesn't make sense. We want to make sure that when we're doing this, we do this after we actually create the tables. And this goes back to my earlier definition of how we first make our database, then we make our tables, then we make our primary keys, and then finally make our foreign keys. And so that's the best practice for the use of the alter command, because it means we've actually thought about the structure of the database, we figured out all the dependencies and the structures that go along with it, and then after we've actually created the tables, then we link the tables to the associated primary and foreign keys. Bad practice, however, does exist, and sometimes, well, you have to do it because, well, life happens, and that's where you can add and or remove columns to a database. The problem with using the alter command to add or remove columns is you run the risk of causing other problems within the data because it may not match up. You might have a whole bunch of nulls you have to handle or provide some other information to the actual structure itself. So it's really best that you don't use the alter command as often as possible. In fact, you want to use it only for the idea, like I said, of after creating the database, you want to make sure that you only use the alter command to add primary and foreign keys when you've got those relationships defined. Great reason to have normalization happen before you actually define structures. The alter syntax, as we can see right here, we're going to alter table universe. We're going to add a primary key ID. It's enclosed in parens. Alter table characters, add primary key ID, also in parens. But that's for the primary key belongs to the characters table for the bottom one and belongs to the universe table for the top one, because again, we're working with that specific table right there. If we're doing a much more complex one with actually a foreign key, again, we have the alter table. We give the table we're talking to. We're going to name the constraint using the foreign key structure we have where it says foreign key, then the opposite table, then the table we're in right now. We talk about what the foreign key is actually referring to inside the database, references the other table and which field it's working with, and then we have the on-delete cascade and on-update cascade, so data referential integrity is maintained across that. And we'll see that again as we look at other things we're doing with foreign keys and practicing information sharing on other tables. We've already talked about it in earlier videos, and we'll continue to talk about it as we go along. The drop one, however, is a little even more powerful than the alter because drop destroys the structure. It's going to take it all down. Yeah, I know. It's a bit insane. But it takes away the structure and any and all data attached to it. So if you have a structure that exists, if you run a drop statement, all the data, all of it is going to go, whoosh, it's gone. And if you haven't done a good backup, it's irrecoverable. And that's really not what we want to see. So there is no prompts or warnings. We're going to see that in an example when we actually go and run through the command line and do this. But it happens. It's done. You can only specify one database at a time for dropping. So if you can drop a database, even if you're using other databases, that's a big problem. And this is one of the main reasons why you really want to make sure you handle things like squirrel injection, because you don't want to be able to have someone be able to alter your database when you're actually in the middle of using something else. You can, however, drop multiple tables in a single statement using commas to separate them, even if you're out of other databases. Again, we don't want that to happen. So again, when you're using the drop command, you want to make sure you're doing this very carefully and handling it correctly. And you only get errors if the specified table is not found. Yeah. So if we're doing that, we want to make sure we keep this in mind. Thanks, Skrillex, for that great example of how we can actually do the drop the base. And we'll take a look at that again in coding here when we get to the final of the lecture. The syntax, as you can see, is really quite easy. We have drop table name, drop table if exists, and drop database. It's really, really basic, and so it doesn't take a lot of work, and so you want to make sure you actually check things out before we actually run them. The next statement that's included inside the DDL structure is the truncate command. Now, truncate, although it actually deals explicitly with data, it's often included with inside the DDL command because it does the work of doing both a drop table and a create table in one single statement. And it's a very powerful tool. It's a wonderful way to remove all the information out of a database. It's the most efficient way, in fact, to do so. But it's usually included with inside the DDL structure because it's such a powerful tool on that. And let's take a look at the code we're going to run to actually make this happen. And so as you can see right here, I've got the code written to actually create the databases, and so we can test some stuff out by using the create statements, so we can actually build that. And also we have some code we're going to use to actually drop some databases as well. So we're going to go ahead and take a look at that inside the terminal for MariaDB. We're going to switch to that screen right now. So we're inside our MariaDB system. As you can see right here, I went inside there, MariaDB, and we're going to tell it database we want to use. And so I'm going to type in use, and then the alternate universe. And so I'm now inside the alternate universes database, and if I show tables inside here, you can see it's an empty set. There's nothing inside my database because I haven't done anything with it yet. So we're going to go ahead and grab the stuff to create those databases and make that happen. So I'll copy the tables database information and paste it in. And we've got that right there. So created table characters, it added all the information right inside there, and we're putting it in there. We're no rows affected. Wonderful. We have our structure. Okay, we've got our universe table added to that as well. And so we can create tables inside that. As you can see, it doesn't take a lot of work. We just simply have to create the information in there, put it in there. As you can see on screen, we have our name, the type it's working with, and any parameters it's working with. And because we're always using not null as a default type, we explicitly put that at the end of every single line we're working with. We have our same thing here inside our universe table. Same basic approach, so we can have that happening. We can have information about that explicitly defined in advance. So we have that ready. I'm going to go back and grab all the stuff to put in the primary keys and foreign keys and just paste it in all at once. Because they're separated by semicolons, it's okay to do so. So we're going to go ahead and just copy that code, move over, and go back to the terminal, and we'll just paste all that in right there. And now we have our structures on there. We have everything in there all together, ready to go. So we have the information added within our structure. So we have those lovely information systems happening. So our tables are now linked together. And we can go ahead and take a look at that inside our system right here. I'll refresh my PHP, my admin. And there's my lovely alternate universes system. There's my characters table and my universe table. Okay, I have my structure right here. I go to my characters table. I look at the structure on it. And as you can see, my universe one right here, it has a relationship. If I go to the relation view, I can see that my foreign key universe characters has the cascade relationship to the universe database, talking to its alternate to the alternate universe database, talking to universe table and its ID. So I have that information linked directly right there. So the foreign key is built in directly to it. So my relationship is already put together right there perfectly for it. As you can see, I have a couple other examples right here. So if I take a look over here at the dead manga, and there's nothing inside the exports table, but I do have stuff inside the products table. Also my demo for drop, which has a full table structure of information. And so we're going to take a look at what happens inside that so we can actually delete the stuff that goes along with that. So let's go ahead and switch back over to the command line, and let's handle what happens with that using code. So we're going to go ahead and look at what we're going to be doing inside that database so we can see what we're going to happen to the code. So we're going to switch to the database of the demo for drop. We're going to select everything out of the table and just take a look at it. We're going to drop a table if it exists, then try dropping it again, and then drop a table we know exists for sure, and then watch what happens when we delete other information that we already know it's inside there. So we're going to go ahead and switch the code for that and make that happen. So we're going to go ahead and use and then demo for drop. Okay, and so we changed to the demo for drop database. Again, you can automatically know that by looking at the prompt in here inside MariaDB. We've got that right there. And we're going to just do the command right here, and we're going to choose the select everything from exports so we can grab all of that. And as you can see right here, there's a whole bunch of computer science teachers listed in my exports table. We've got that information, and we're going to go ahead and we're just going to drop the products table. Okay, it's dropped. I'm going to run the same code again. So drop table if exists. Okay, no problem. But if I try and drop a table that has already gone, unknown table name demo for drop.products. So you only get an error if it's already been deleted or doesn't exist in the first place. We're going to go ahead and drop that table exports because we know there's stuff inside there. So we'll just go ahead and get rid of that. And we have in show tables, we have the cells and cell statements tables. Let's go ahead and take a look at inside the cells table, see if there's information inside that. So we'll head select everything from cells. We've got a whole bunch of stuff in that. There's a table in that. Change the same thing right here, but change the cell statements. Lots of stuff inside that. And if we just drop the database, okay, notice it automatically changed my prompt because that database no longer exists. I can't even see it. If I try and use demo for drop, it's unknown. It doesn't exist anymore. I've destroyed that data, so I can delete it right inside there even as I'm actively using it. So it's very important that when you handle anything with the drop or the truncate commands that you don't do that incorrectly. So let's go ahead and go to the manga table. And so I'm in the dead manga table, and I have inside here, I have show tables. So I have my products table, and my exports table I already showed that it was deleted on that. It was empty, but my products table does have stuff inside it. And so we're going to go ahead and call the truncate command on the products table so we can see exactly what happens. So select everything from products. We've got all that stuff, and we're going to just do truncate products, and we'll just go up an arrow so we can show everything, and it's empty. It's completely gone. That's so fast. It destroys everything. And so we have a lot of power we can do with that. And so that's the power we have inside the DDL statements, is we have the ability to change the entire structure of the database. So let's go ahead and take a look back at that lovely little lecture set really fast. So we did a quick review of how we could use a create table. We can do modifiers on that. We did a quick review of how we could actually alter the table by adding keys, both primary and foreign. And we saw that we can actually do drops because that dropping the database destroys everything that goes along with it. It's not just amazing because of the massive power of a good baseline. But there we go. That's a great example of how you can use the DDL statements inside a database. Hope this can help you out, and have a great day. We'll talk to you in the future.